Dear students, I start with lecture 4 of Math 201. In the previous lecture, we have discussed definition of continuity, and before some lectures we discussed definition of limit. In this concept of limit and continuity, I want to again giving you the difference of limit and continuity, and you have already understood it with the discussion we made. All in all, if you think the definitions of limit and continuity are very much similar, but there are differences. So just we start this lecture, but I suggest you to read this definition for few times. So, for epsilon positive, there is delta positive such that this happens. And as I said in the earlier, this is 0 less than means xy never be AB. The value is less than delta and this value is less than epsilon. Then we say that limit of function at point AB is F, and this is notation. In the continuity part, for epsilon positive, there is delta positive such that difference between this and AB is less than delta, but there is no restriction that xy may not be AB. This restriction is not in the continuity. And therefore f of xy minus f of AB less than epsilon, and then we say that f is continuous at point AB, and this is the limit. So as I said in the previous lecture, and also you have observed, there are three differences. The first difference is that xy never hit AB in the limit, but it must be AB sometimes in continuity. The second difference is L, and second difference is f of AB, and the third difference, the domain of f need not be contained point AB, but domain of f in the continuity part must be covered by domain of F. So keep these things, both definitions in your mind. I start with very important theorem of this chapter, and this is the only theorem in this unit. So, we are going to prove this theorem. Here phi is continuous at point A and phi of A is B. Limit f of xy at point AB exists and is equal to n, then we wanted to prove this. So, before we start this theorem, again I suggest you that read this statement by pausing this video here for a few moments and understand what we wanted actually. So see that. it xy tends to a b, f of xy is equal to L. This is given to us. Here phi is continuous and this limit is equal to L. It is given to us. And so by the definition, therefore for given epsilon positive, there is delta 1 positive such that zero less than x minus a square y minus b square is less than delta 1. This implies less than epsilon, and we say this as equation number 1. So this is just we are using the definition. Now we are using what is continuous. At point A. Therefore, for given delta 1 positive, there is delta 2 positive such that this as equation number 2. Here phi is continuous function. Phi is continuous function in one dimension, and this is in the two dimensions. So always keep in mind that whenever we are in a one dimension or we are in a two dimension, choose delta equal to minimum of delta 1 by root 2 and delta 2. Therefore, whenever we say x minus a is less than delta, implies x minus a is less than delta 1 by root 2 and x minus a is less than delta 2. But the second assertion, if you take this one and this one, this implies this value is less than delta 1 by root 2. This implies the second portion, phi x minus phi a is less than delta 1 by root 2 because of equation 2. So whenever I say x minus a is less than delta, this implies x minus a Or I can say directly x minus a square plus 5x minus 5a square. This is less than square root of delta 1 by 2 square, delta 1 by 2 square. And therefore this is delta 1. This is less than delta, means this is less than delta 1, and this is also less than delta 1 by 2, and therefore their squares are less than by their squares. As this is less than delta 1, this is less than delta 1, this happens to be less than epsilon. Therefore 1 implies phi of f of x, phi of x minus x is less than epsilon, and therefore limit x tends to a, fx phi x and therefore just simply we are using definition of continuity and limit. Mostly I use continuity in the one dimension during this theorem and limit in the two dimension, and I suggest you to write this theorem so many times, because within this unit only one theorem is there which can be in your exam, and it is very important as per point of exam. So students, we have learned this theorem thoroughly, and at this juncture I would like to explain this theorem once more. So read this again, and then I repeat the same theorem with you, and then we go further in the syllabus. Phi is continuous at point A and phi A equal to B. Limit xy tends to AB, f of xy exists and is equal to L. Then we want to prove that limit x tends to A, f of x phi x exists and is equal to L. And therefore, first we use this definition. For given epsilon positive, there is delta 1 positive, such that this happens. Now we use the fact that phi is continuous, and as phi is continuous at point A, for given delta 1 positive, there is delta 2 positive, such that this value less than delta 2 implies this value is less than delta 1 by root 2. And now we choose delta is minimum of these two numbers, this one and this one. So once I say x minus a less than delta, means x minus a is less than delta 1 by root 2 and x minus a less than delta 2. As this is less than delta 1 by root 2, this is less than delta 2. Yes, this is less than again delta 1 by root 2. Now combining these two things, whenever x minus a less than delta, this value is less than delta 1, and this is less than delta 1, means this value is less than epsilon. And therefore this limit is equal to L, and that we wanted epsilon. So it is very straightforward, but some writing practice and your clear understanding is required. Okay? Now we want to find we want to discuss limit of this function f at point origin. And this is the definition of the function is tan inverse y by x, both are not 0 and is equal to 3 if x and y are equal to 0. Here, as this is a first sum, and we have very limited options are there. As this is first sum, here I will explain you what happens actually. Suppose this is a origin. Origin in R. This is real line. In real line, if you want to reach up to 0, then there are only two ways you can reach up to 0. Either by decreasing here from this side or by increasing from here by this side. And we used to call this is positive side and this is negative side of 0. Or any number. If I write 3 here, then this is positive side of 3, this is negative side of 3. Because whenever we are in R, we have only two options. Either by decreasing, you can reach 3 or some point here 0, or by increasing you can reach there. તમે એવું સાંભળ્યું છે તમે જ્યારે 12થના કે 100ના સમ્સ કર્યા હોય કે જ્યારે તમે લોઅર લેવલ પર હતા અને ફક્ત રિયલ લાઇન ઉપર તમે જ્યારે કોન્સન્ટ્રેશન કરતા તો આપણે એવું સાંભળીએ કે જમણી બાજુથી ડાબી બાજુથી અને બિંદુ પાસે ત્રણેય કિંમતો સરખી હોય તો એને એ આપણે સતત કહેતા કે અહીંયા લક્ષની વાત કરી તો લક્ષ છે એવું કહેતા. તો અહીંયા લક્ષની વાત છે તો જમણી બાજુ ડાબી બાજુ બે જ આવશે. But whenever we are talking in R2, R2 means what? If we want to reach, this is x-axis, this is y-axis and this is origin. If you want to reach origin at 0, 0, then there are how many ways? This is real line actually. This is positive side. This is negative side, this is imaginary line positive side, this is negative side of imaginary line. Now how you can read here by decreasing from this side, by increasing from this side, by decreasing from this side, by increasing from this side. You can reach 0, 0 by all these things. All these lines will reach 0. And these lines are called, what we call them, y equal to x. Is a line having slope m. આપણે ગુજરાતીમાં શું કહીએ છે એમ ઢાળવાળી અને ઉગમ બિંદુમાંથી પસાર થતી રેખા. હવે જેટલા ઢાળ બદલશો as you changes the slope m, this line will differ, and all these way you can reach up to origin. So one way to reach up to origin is y is equal to mx. You think only this way you can reach up to origin? No. This is y equal to x square. Y equal to x cube. Y equal to x raised to 4. Y equal to x raised to 5. And any power of x will reach origin. So you understand that there are so many ways to reach up to origin. Dear students, this is a very important notion, idea of continuity in two dimensions, and you should think that I will solve this sum in the next lecture. With this new idea, I give it to you in your mind. You have to enlighten it I stop this lecture here and see you in the next lecture.